Hey everyone, I am Tapati Paul, the student of Coochbehar Government Engineering College in the Department Electronics and Communication Engineering in 3rd year. I am here to give a presentation on the topic Operation of Mosfet. Let's start with the introduction. The metal oxide semiconductor field effect transistor MOSFET is a field effect transistor where the voltage determines the conductivity of the device. It is used for switching or amplifying signals. The ability to change conductivity with the amount of applied voltage can be used for amplifying or switching electronic signals. Next, we have the construction of MOSFET. It is a 4-terminal device with source, drain, gate and the body terminals. The body is frequently connected to the source terminal, reducing the terminals to 3. It works by varying the width of the channel along with charge carriers flow. The charge carriers enter the channel at the source and exit via the drain. The width of the channel is controlled by the voltage on an electrode called gate, which is located between the source and the drain. It is insulated from the channel near an extremely thin layer of metal oxide. A metal insulator semiconductor field effect transistor or MISFET is a term almost synonym with MOSFET. Another synonym is IGFET for insulated gate field effect transistor. Next we have the types. MOSFET works in 2 modes. One is depletion mode and another is enhancement mode. The depletion mode is basically equivalent to a normally closed switch. This occurs when the transistor requires the gate source voltage to switch the device off. And the enhancement mode is equivalent to a normally open switch. This occurs when the transistor requires a gate source voltage to switch the device on. So, there are 2 types of MOSFET, P-channel MOSFET and N-channel MOSFET. P-channel MOSFET. So, as you can see, the drain and the source are heavily doped P+ region and the substrate is in N-type. The current flows due to the flow of positively charged holes, and that's why this is known as P-channel MOSFET. When we apply negative gate voltage, the electrons present beneath the oxide layer experience repulsive force and are pushed downwards into the substrate. The depletion region is populated by the bound positive charges which are associated with the donor atoms. The negative gate voltage also attracts holes from the P+ source and the drain regions into the channel region. N-channel MOSFET. This is exactly opposite of the P-type. Here, the drain and the source are heavily doped N+ region and the substrate is P-type. The current flows due to the flow of negatively charged electrons, and that's why this is known as N-channel MOSFET. When we apply the positive gate voltage, the holes present beneath the oxide layer experience repulsive force and the holes are pushed downwards into the bound negative charges which are associated with the acceptor atoms. The positive gate voltage also attracts electrons from the N+ source and the drain region into the channel. Thus, an electron-rich channel is formed. Now we have the operation of MOSFET. The working principle of MOSFET depends upon the MOS capacitor. The MOS capacitor is the main part of MOSFET. The semiconductor surface at the below oxide layer is located between the source and the drain terminals. It can be inverted from the P-type and the N-type by applying positive or negative gate voltages. So when we apply positive gate voltage, the holes present under the oxide layer experience a repulsive force and the holes are pushed downwards with the substrate. The depletion region is populated by the bound negative charges that are associated with the acceptor atoms. The electrons reach and the channel is formed. The positive voltage also attracts electrons from the N+ source and the drain regions into the channel. Now, if a voltage is applied between the drain and source, the current flows freely between the source and the drain, and the gate voltage controls the electron in the channel. If we apply negative voltage, a whole channel will be formed under the oxide layer. This is the operation of MOSFET. Now we have some applications. MOSFET is used in amplifiers. It is used in regulation for DC motors, construction of chopper amplifiers, switching and amplifying signals, etc. Now we have some advantages like it generates enhanced efficiency even when functioning at minimal voltage levels. Next, there is no presence of gate current which creates more input impedance which further provides increased switching speed for the device. Next, this device can function at minimal power levels and uses minimal current. Next, we have some disadvantages like When these devices are function at overload voltage levels, it creates instability of the device. And as because the device have a thin oxide layer, this may create damage to the device when stimulated by the electrostatic charges. So that was it for my presentation. Thank you for your time.